Hey everyone, welcome to my channel. So, if you're looking for some beginner friendly ML projects that you can add into your resume, or if you've just started machine learning and are looking to learn through projects, this is the right video for you. Today, we'll be doing a project. It's called car price prediction. So, we'll be using data from Kaggle, which is a vehicle data set. So, we have taken used car data from websites, which has been extracted here. It contains information about cars. It has features such as name, year, selling price, kilometer driven, fuel, etc. As you can see, we can get this information. So, these are the names, and we have year in which they were bought. We also have the selling price, which is going to be our the target that we are going to predict. It also has other features as well that will be getting deep into later on. So this is it for the data. I'll put in the link in the description box. We also have a download option here, so you can download for yourself. Moving on to aim of the project. So number one is to predict the selling price of the cars, and we'll also perform EDA, which is exploratory data analysis, so to get a bit better understanding of the data that we are working with. So these two are the aim. Now we're moving on to the flow of the project. So number one is importing the data, pre-processing, moving on to scaling, EDA. Then we'll split the data into training set and uh, test set, and then we'll train and then evaluate the model. Library used are Pandas, NumPy, Matplotlib, Seaborn, Plotly, and Scikit-learn. So if you know the basics of these libraries is well and fine. Even if you don't, we'll be moving step by step so that you can grasp a better idea about these. So you don't need to worry about that. So now moving on to the applications, we can see that this project can be applied to online car marketplaces so that we can predict the selling price of used car based on the features. It can also be used for individual sellers who are looking to estimate the value of their car before to put it on the sale. So these are all for the application. I hope you got a brief idea about the project. So now let's code in Colab. So there you go. Now we have the Google Colab environment. Here in number one thing that we'll start by is importing the important libraries. So I'm importing, just a second. Okay, now we'll write import numpy as np. So we'll be importing the numpy library. Moving on to pandas as pd, then importing matplotlib.py plot as plt. Then we'll be importing Seaborn, import Seaborn as SNS. Okay, so we have done importing the libraries for now. If we need another library, we will do it later on. Now we'll move on to loading the data. So load the data. Okay, the data. Okay, so now what we'll do is we'll use the pandas library to read a CSV file. Read CSV underscore. This is the syntax to read a file. What we'll do is we'll go to this Kaggle website, download the dataset into your system, and after we have downloaded, we can see the download icon. Just a second. Yes, so we can download either from here or from there. We can go from this file section and upload our files that I have already done. You can see the below the file is being loaded. After the file is loaded, it might take a while depending on your internet connection. I'll copy the path and paste it inside the read CSV bracket. So we have done loading the data which is stored in the variable data. Now what we'll do is try to analyze the data. So we'll do data.head, that will give us the first 5 rows of data. I'll do data.info to get more information. So these are few steps that you can do. These are very useful while starting off with the data. So we can see that there are different columns, name, selling price, etc. We can also see that there are categorical columns, numerical columns, and some are mixed as well. So that's it. When we go to data.info, we get a better understanding of the data type that each column has, the null values, non-null values, etc. So we can see that lots of them are of object type or string type. 3 or 4 of them are numerical type. Moving on to pre-processing. So And next what we'll do is try to find out the number of missing values. So that we do is by is null dot sum. So this is how we find the missing values in each column of the data frame. So as we can see that the beginning columns do not have any missing values, but these 5 columns do have. We can also see from the above information as well. So what we're going to handle is we are going to drop those missing values because they are less in number compared to the whole data set. So drop an a and axis, short letter a, axis equals 0. So yeah, this will drop the columns which has missing values. Next what we need is that if you see these 3 columns, which is mileage, engine and maximum power, we see that they have number plus some string. So we need to extract numbers out of these columns. Also they're in decimals, so we'll keep that in mind as well. So we'll create a function which is convert to number, and we'll take argument as string. Let's say s, let's call it s. Now let's initialize a variable d to an empty string. Now I'll start a for loop which says that, wait a second, for I in list s. So it will traverse in the each column and each cell. Now I will try to compare if I is one character of a string or a cell. So we'll compare that if I is digit. Is digit will check if the this character is numeric or not. Also we are checking for the decimal point as well. So I equals dot. If this is true, we are going to concatenate or add I into the D. Then next we are going to return D, but we'll put it inside eval so that it get converted into number or specific data type. So that's it. We are going to run this section. Let's see for any errors. No. Okay. Moving on, we'll apply these into the columns. So we have mileage, engine and max power. So we're going to apply this function to that columns as well. So data mileage dot apply convert to number. Okay, just a second. Yes. We'll copy paste for the next two, engine and maximum power as well. That's done. We have done for the maximum power as well. Now, okay, so it seems like we're done. Now let's just visualize. We just do data.head to see if they have been changed or not. So yes, now we see that the mileage, engine, maximum power have been converted into numeric values, which is what we wanted. Moving on, we try to, so one thing that we note is that the torque column and the name column are very random, and they have been like we cannot extract any features and information from them as of now. So we are going to drop them, which is also not the right thing to do, especially with the name section, but we do not have any other option as well, because name also factors the price as well. So if it's a Maruti or Honda, the price will vary as it is. So but since we do not have the brand name extracted, we'll just move on with dropping them. So yes, that's done. So now when we look to the data, which is data.head, just a second. Oh, why is taking long? Yes. So now we see that oh, it's not done. Yes. So data head is gone. We have all the numeric columns plus categorical columns. So now let's just do what we do is take this 4 columns and try to find out its unique value. So let's say data dot fuel dot unique, and let's see how many unique values are present in them. Also we'll check for the let's say owner dot unique. Wait a second. Okay, so as we see that the fuel unique has diesel, petrol, LPG, CNG, and this, as you can see. So now what we'll do is we'll encode them. So there's a library called label in pre-processing label encoder in sklearn, scikit-learn library, that will help us to convert these into numbers forms. If they are like diesel, petrol, LPG, and CNG, it will be converted to 0, 1, 2, or 1, 2, 3, 4, like that. So label encoder equals preprocessing.label encoder. This is how you call the label encoder method. We are saving it into label encoder short. Now what we'll do is we will use data of the columns that we want to apply, label encoder that we saved, dot fit transform. So this is the syntax that we use, and pass on the column. So basically we are storing it back into the column, so we are not adding another column, we are removing that column which contains LPG diesel, and we are converting it to numbers or giving it labels as 0, 1, 2, 3, 4 or 1, 2, 3, 4 as it is. So let me change it for all the 4 columns that we had: fuel, owner, transmission, and seller type. Okay, we are done now. So now what we'll do is we'll try to see the data again. So first run this cell. Let's see, we don't have any error. Okay, now let's just go and do data.head. I'm taking 10 to visualize the whole 10 row. So we see that all have been converted in numeric, but we also see that these selling price, kilometer driven, and these all are from different scales. So some are in millions, thousands, and some are in just 1 to 10. So let's just do what we call as scaling, so that the model is it is easier for the model and will get better accuracy from this. So I'm using sklearn library as again. So from sklearn.preprocessing, pre-processing, we'll be importing standard scaler, min-max scaler. Yes. So yes. Now we'll create 2 variables and we'll call this, so scaler equals min-max scaler, and scaler for the y column again. It's min-max scaler again. Just a second, I'll change the name as capital, this also capital. Next what we'll do is we'll define 2 variables again, x and y. So x will keep as data dot drop column, so we'll remove just the selling price column, just selling price. Oh, put it in, sorry, square bracket, list of columns. Okay, now we'll do dot dot values to convert it into NP array. Now we'll take y is equal to data and just the selling price column, dot values. Now what we do is run this. So that's it. Now we'll just look at the shape of x. Wait, okay, let's just print the shape. So x dot shape, or we can also print the shape of all the 3. So let's say print data dot shape, print x dot shape, and print y dot shape. So if we now see, run this, we'll see that how the data has been split into. So we have 10 and 1, and the row number of rows are same for both of them. So this is very mandatory that if you are doing this, the shape should come exactly this. Now let's apply this scaling into the r x and y columns respectively. Transform, just a second, dot fit transform, second option, y. Okay, so let's just run this cell as well. Okay, cool. Now moving on to our EDA, which is exploratory data analysis. Now we'll visualize the data, we'll form like correlation matrix, we'll form it into heat map, we'll also plot scatter plots in order to gain better understanding. So yes, this is it. Let's just code. So we'll import plotly graph objects. That's also used for plotting. Plotly dot graph underscore objects. Just a second. Dot graph underscore objects as go. So I'm saving it as go. Next, correlation matrix. It's a variable equals. We're working on data, so data dot cor function. Okay, next what we'll do is we'll define two variables, corr, and also one is layout. I'll tell you why. Because when we pass this variables to figure, which is fig variable, which will show later on. So fig is to go dot capital F, no, just a second, capital F figure, and herein we'll pass data equals to corr and layout as layout only. I think we have given the same name, right? Yes. Next is figure dot show. Yes. So now coming on to corr, we'll write go dot heat map, capital heat map in bracket z equals. Now we'll give three, z, x, and y. We'll also give color scale and color bar. I'll put it this for you. So I'll just copy and paste. Okay, so yes. So this is the thing that we have z, x, y, color scale, and color bar. Correction here. Now coming to layout, we'll write go dot layout, not here, here. Yes. So go dot layout, capital L, and in bracket we'll give title, x-axis, y-axis, and height. So I'll put a bracket. So we are giving title equals heat map of correlation. Same will give axis, y-axis, and height. So there you go. So we have the whole cell. Now I'll run. Okay, cool. So this is the heat map of correlation. As you can see, we are able to analyze a lot. So if you see the upper diagonal as well, so this cell shows that engine and maximum power have a good correlation because they lie in this range. We can also see selling price and maximum power, or selling price and engine, they have a little bit of relation. And for like maroons, like transmission and maximum power and mileage and engine, they have a very negative correlation. So these all will help us to find out the relationship between them. We are able to better analyze the data as well. Moving on, let's plot some first, just a second. Yes, let's plot a scatter plot. So for column and data columns, we'll use SNS library that we have imported on the top, sns.scatter plot. In bracket we put data equals data. For column we have x, for x we have column, and for y we'll keep it as constant as only selling price. So we'll analyze all the columns against selling price. Okay, cool. Now we'll give the plot title as well. So plt.title, we'll keep this, just a second, t, oh no, t is extra. So we'll give it f as a function, so that because inside we have an thing to evaluate plot between, and in double parenthesis, no, it's a double curly braces I mean, column and selling price. So this will change as per our need, as per as a column, and plt dot show. Okay, oh, what's this is only one seats. Oh, does not look right. Wait a second. Let me see what's wrong. No. Why do we have three there? Okay, just a second. Oh, we missed a bracket here. So plot dot show, and then we have parenthesis after plt dot show. So let me add this. Okay, done. So this is plt dot show. Now we'll see. Yes. So now we see is the plot between see year and selling price. As we see that over the years, the selling price have increased. So if the manufacturing year is very less, we'll get price as well, lesser price. Then we also have kilometer driven versus selling price. So if less kilometer driven, the price is higher, and vice versa. We can see the graph. We also see, because since fuels have only 0, 1, 2 and 3, so we'll see that for one fuel and 3 fuel we have maximum selling price. So probably for 2 there might be cng or such, I don't know. Same goes for other columns as well. So these columns will help you better understand your data. Suppose mileage, we see that the data is, there is not so much of trend going on between mileage and selling price. Then we see maximum power, etc. So yes, feel free to sit down and work on these and try to gain analysis. I'll move on to splitting the data set. So it's always necessary to split your data set into training set and test set, so that you can analyze it on a fresh test set, so that you can see if the model is performing fairly well or not. So I'll use from sklearn.model selection, we import train test split. We get x train, let's form 4 variable train x test, then we have y train, then we have y test. So these are the 4 variables that it will return. We'll pass on train test split function, just a second. We'll pass on x, y. We'll also give test size as 0.3, so 30% of the data will be used as test data. And let's give it a random state, although it won't make a much difference. It will just provide us on the same split if we do it later on as well. Next, let's just analyze the size and shape of training and test. So yes, I have written out already. So let's see. Yes, so this we can see that it has been split. So 5534 and 2372 for test set. Now moving on to we'll create a function which is root mean square error. It will be used for evaluation of our model. So we'll pass on to prediction and test, and the formula is fairly very simple. It's prediction, what we have predicted, our model has predicted, minus test data set to the power 2 dot mean, so average of all that. So it will give us root mean square error. It will help us to analyze if our model is doing well or not. So yes, this is it. Just balance the bracket. Okay, where, I think it's right. I think it's correct. Just a second, it's loading, I guess. Okay, so I guess we're correct. Moving on, we'll move on to random forest regression that I'll be using. If you want to know more about this regression and why I'll be using this regression, let me know in the comment section. I'll make a separate video for it. But here we are using a random forest regression, which is very used for a model which is very simple like this one. We do not have large amount of data and we do not have many complicated features. So we'll be going on with simple random forest regression. We will just a second, let me create random forest regression. It's also kind of regression model. So if you have learned about regression, you'll probably know it. Okay, moving on, let's write the code for it. So we'll use sklearn ensemble dot ensemble, and from here we'll import our random forest regression, random r capital random dot forest regress. We'll also import matrices so that we can evaluate sklearn dot matrix import r2's under root square score max error and mean squared error. Oh, just a second. Squared error. Now what we'll do is we'll first initialize our regression model. So since our model is fairly simple, we'll initialize rf is equals random forest regression, and we'll just give estimators as equals 10 because we have comparatively lesser data. So we give bracket n estimators equals 10, and let's give it a random state as well. I'll give a random number, let's say 45. Yes. Okay, now what we'll do is we'll fit our training set into the model. So rf.fit xtrain comma ytrain. Now we'll do prediction. So we'll store the prediction ypred rf equals rf.predict xtest. So we'll be using xtest to predict, and we'll store it in ypred rf because it will be predicting ypred. Now we'll utilize various metrics and find out. So calculating various results or metrics score, let's write scores or matrices. Okay, so first is rmse rf rf, which is equal to rmse. Will utilize the function that we've created above. So we'll write y test and we'll pass on ypred rf to compare in order to find out the values. For the same, we'll do the same for all, like r2 score, maximum error and mean squared error as well. So this is how it looks like, and we are doing the same for all by passing y test and ypred rf and calculating. So let's run the section, and we're printing it as well. Oh, it's showing an error. It's saying instance 45 instead. It has problem with random state. So it has problem with random state. So now the problem has been rectified. So yes, this is what we got. So we have rmse r2 score error, maximum error and mean squared error. So these are, feel free to analyze the results and make expand this project further. So this is it for the project. I hope you understood. If you have any doubt, let me know in the comment section below.